Hello students, in this video we are going to see what the root mean square error is. So we will use the data and the function that we have plotted before. So what is the idea of this root mean square error? It will show you, this number will show you how well your function formula fits your data point. The first thing we will do is we are going to calculate the prediction according to our exponential formula. So we will type here what the y value is for every single x value. So for instance, I'll use the formula before. You can type here equal 472 times 1.011 and then power, and we will take every single x value which is in the cell A. So just click there once for A2 and press enter. So this will give you the result of the calculation according to your formula. So if you copy that down, the spreadsheet will just calculate that right away for you automatically. So you can see here sometimes your function will give a higher value compared to the observed collected data. So for instance, 10 years from 1900, according to your function, the population will be higher than the real collected data. And in some other years, the predicted value is actually lower. So for instance here, you see that the predicted value by your function is lower than the real collected data. So what we want to know now is how big this difference is, whether it's actually considered small or great difference. So in this case, first we are going to say, okay, let's calculate the difference between the prediction and the observed collected data. You can use a formula for this as well on the spreadsheet, and copying down easily you can see the difference for every single data point. Right now there are some positive values and some negative values, obviously, because sometimes your function is higher and sometimes it's lower than the real data. So to make sure that we talk only about positive number, what we could do is we are going to square every single differences of the prediction. So I will say equal this cell squared, for instance, and then again we can do that easily automatically by copying the formula down. So once we have this, we are now going to try and see what is the mean discrepancy between observed and prediction. But then keep in mind that this was the squared differences. Anyway, I'm going to try and show you here. Okay, let's take first the sum. We are going to calculate the mean, but let's first find the sum of all this column here. So that's the sum, and then we are going to calculate the mean. So of course, because there are 1, 2, 3, 4, 5, 6, 7 data points, we are going to say this sum divided by 7. So that will be the mean of the squared differences. And then now, because we of course realized that this was not the real quantity that we have in the beginning, but a squared unit of the original one, we will try to put it back into the real quantity unit. So we will actually square root it. We will square root this mean here. So I'm just going to put here a root. So we are going to have equal square root. The command is sqrt of the previous cell. So we see this number here, 57.556. This number shows us the root mean squared error. So meaning this number shows you how big the data discrepancy is and with how well your formula fits the data point. At the moment, it doesn't really show you that much. We can't really say whether it's big or small, but it will be useful if you have another formula you want to compare, and you can calculate in a similar way the root mean square error, and then you can compare them. So the smaller than this number is, of course, then it means your function is a better fit. So again, I repeat, if you compare 2 or 3 different functions, which one fits better, then the one with the smaller RMSE value is the better fit. So I hope this makes sense. You can try it yourself with your own formula. Good luck!